Okay, so this is 8.1, two variable linear system. So this is what you've probably seen in Algebra 1, but we're just going to talk about it again. So two variable linear systems. If you would like, you can go ahead and start on the opener if you feel like it, and we'll keep going after that. Okay, so a system of equations is any set of simultaneous equations. A solution to a system of linear equation in two variables is an ordered pair that satisfies both equations in the system simultaneously. So the point of intersection. So I have this line here that is x plus 2y equals 2, this line here which is x minus 2y equals 6, and then our point of intersection right here is the one point in the two graphs that works for both equations. So that's what we're looking for here. So here's some vocabulary. A system of equations that has at least one solution is called a consistent system. So on the other hand, if it has no solution, it's called an inconsistent system. A system of equations that has exactly one solution is called an independent system. And then one that has infinitely many solutions is called dependent. Okay, so we remember back in Algebra 1 how to solve by substitution. We had graphing and we also have elimination. So to solve this by substitution, the best way to do this is to figure out which one is the easiest to solve for. So I notice in this top equation here that y is really easy to get by itself. And so I have 9 minus 5x is equal to y. So what I do is I replace the y in the second equation. So we have to make sure that what we're doing in the first one, we're not plugging it back into the first one. So we have negative x plus 3 times what we had for y. So 9 minus 5x, and that's equal to 11. So negative x plus 27 minus 15x equals 11. We can go ahead and combine to get negative 16x is equal to negative 16. So therefore x has to equal 1. Now this is where we're not done yet. Now what we do is we take the 1, go back up here to our equation at the beginning, and we plug it in. So y is equal to 9 minus 5 times 1, or 9 is equal to 5 minus 1, y is equal to 4. So our final answer is an ordered pair, 1, 4. This is the point of intersection. So now let's think about it. Is this consistent, inconsistent, dependent, or independent? Well, we know that it has at least one solution, so it has to be consistent, and it has at least one solution, so it has to be independent, but it doesn't have infinitely many. Now let's talk about the addition method. This is the same thing as elimination. What we're trying to do is we're trying to eliminate one of the variables. So either we need to get rid of x or we need to get rid of y. It doesn't matter. So I'm going to choose to get rid of x. So in order to do that, I need to have them both with the same coefficient. So I'm going to multiply the numerator by 2 and my denominator by negative 3. Now why is that one negative? Well, we know that this would become a positive 6x, and in order to get rid of it, it needs to be a negative 6x. So over here, the 2 applies to everything. So 6x minus 8y is equal to 22. And then we have negative 6x minus 9y is equal to positive 12. Now all we have to do is add up. We see that the 6x and the negative 6x cancel. So we're left with the negative 17y is equal to 34. So we get that y is equal to negative 2. So now what we have to do is go back and plug into one of the original functions. It doesn't matter which one. I'm just going to go ahead and choose the top one. So 3x minus 4 times negative 2 is equal to 11 because I replaced that y with what I found y to be. So 3x plus 8 equals 11. 3x equals 3. X equals 1. My ordered pair is 1, negative 2. Now let's think about it. What do we know? Consistent, inconsistent, dependent, or independent? Consistent and independent. Okay, two identical twins can only be distinguished by the characteristic that one always tells the truth and the other always lies. One twin tells you of a lucky number pair. When I multiply my first lucky number by 3 and my second lucky number by 6, the addition of the resulting numbers produces a sum of 12. When I add my first lucky number and twice my second lucky number, the sum is 5. So which twin is talking? Well, let's figure out two variables. So first lucky number, and y will be my second lucky number. So let's read these words. So we say when I multiply my first lucky number by 3 and my second lucky number by 6, so that would be 3x and 6y, the addition, so we're adding them, produces a sum of 12. When I add my first lucky number and twice my second lucky number, so my first lucky number and twice my second lucky number, the sum is 5. Which twin is talking? So you can choose to do this either way, by substitution or elimination, and I'm going to choose substitution. So I have my system. I'm going to leave the numerator alone and multiply the denominator by -3. So that gives me the same numerator, not the numerator and denominator, the first function versus the second function. So 3x equals 6y equals 12, and then I multiply the 3 to the second function. So that's -3x minus 6y equals -15. I go ahead and add them up, and I see that I get 0 is equal to -3. So what does that mean? Well, that means that we don't actually have an intersection of these two. So that means that this is probably being said by the twin talking always is lying. So the twin talking always lies. And we know that because there's no actual equation or no actual solution here. If we had gotten a solution for y and x, then we would have been able to say, okay, well, yes, he's true. He's telling us the truth. Okay, a linear system having no solution or infinitely many solutions. So a number of solutions, if we have exactly one ordered pair solution, that's what looks like this, where we have our two lines crossing at one point. If we have no solution, then they're actually two separate lines that never intersect, which would mean that they are parallel. And then if I have infinitely many solutions, that means that every single point works for both of them, so that means that the two lines are actually on top of one another. Okay, so let's go ahead and solve this system. Why don't you take a moment and solve by whatever method you think. Okay, so what I'm going to do is I'm going to do substitution because it seems to be already ready for me. I just have to replace the y. So 15x minus 5 times 3x minus 2 is equal to 10. So 15x minus 15x plus 10 is equal to 10. I see that I get 10 is equal to 10. So that tells me that we have any solution will work, right? Because we have 0 equals 0. So this tells me that I have infinitely many solutions. No matter what we plug in, it'll always work for both of these. So infinitely many solutions, that tells me that it is dependent. So although this system that we just did has infinitely many solutions, this does not mean that any ordered pair of numbers you can form will be a solution, right? And that's because we have to have an ordered pair of x, y that has to satisfy one of the system's equations. So it either has to work in this one or in this one. And there are infinitely many such ordered pairs. Remember, those graphs are going to be right on top of one another. So the graphs are coinciding lines. The ordered pairs are the solutions of one of the equations has to be solutions to the other. So this is how they wrote the solution set. Okay, cost and revenue functions. So thinking if you're selling something, if you're working for a company and you sell things, you have a revenue, so how much you make for selling that item. And you also have a cost, so how much the fixed cost was, and then the cost per unit that you have made. So to figure out the profit you've made, you take the revenue that you've made and you subtract the cost, and you want to see how much money you're going to make, or maybe you've lost money. So when we graph a cost equation and a revenue equation, we can see very easy where the break-even point is. The break-even is where both of those lines intersect, which means that you have made as much money as it took you to make those. So normally what we want is we want our revenue to be higher than our cost. So this is in here is where our profit comes. This is telling us that we've lost money because it's cost us more to make the items than it will sold them, than to sell them. So let's say you decide to start your own company, which is going to produce specialty rugs. The initial cost for setting up the business is $10,000 for the equipment, legal costs, and basic office and advertising needs. It costs $50 to make each rug, and you can sell the rugs for $150. So we want to write the cost function, we want to write the revenue function, and then we want to determine the break-even point and figure out what that means. So to start this, let's write our cost function. Oops, let's redo that. Okay, so the cost function, so we label that as C of x. So that is our fixed cost of our $10,000 plus how much it costs us to make each one. And it costs $50 to make each rug. So we'll say $50 x. So we're going to say x is the number of rugs produced. Okay. So we have our cost function. Now let's write the revenue function. So the revenue function is just how much we can make for each one. So we know that we're going to have R of x is for revenue, and we can charge $150 per rug made. So that's where that came from. So now I want to figure out our break-even point. So that's saying that if we think about it, P of x is what we're talking about for profit. That's when we take our revenue function and we subtract the cost function. All right. So we know our break-even point. We're going to set P of x equal to 0. So we have 150x minus 10,000 minus 50x. We can now combine like terms. We can factor out. So we get that x is equal to 100. So once we sell 100 rugs, we earn as much as it cost to make them. So our break-even point is where we earn as much money as it costs to make them. So it's that sweet spot where those two graphs or those two lines are going to intersect. Okay, a hotel has 200 rooms. Those with kitchen facilities rent for $100 per night, and those without kitchen facilities rent for $80 a night. On a night when the hotel was completely occupied, revenues were $17,000. How much of each type of room does the hotel have? Okay, so we have to set two variables. So I'm going to say that x is number of rooms with kitchens. And then we have y is number of rooms without kitchens. Okay, so now what we need to do is set up our system of equations. So we have 200 total rooms. So we have x plus y is equal to 200 because we have some number of rooms with kitchens and some number of rooms with no kitchens, but in total we have to have 200. We know that those with kitchen facilities rent for $100 per night. So $100 times that, which is our number of rooms with kitchens, plus $80 for our rooms without kitchens, equals $17,000 if we have them all occupied. Okay, so now what we need to do is we need to figure out how many of each room. Well, I'm going to change this one to being x is equal to 200 minus y. So now what I can do is solve this by substitution. So I have 100 times 200 minus y plus 80y is equal to 17,000. So we multiply everything out, and we have 20,000 minus 100y plus 80y equals 17,000. I see now when I combine like terms, I have negative 20y equals negative 3,000. So y has to equal 150. So now that I know what y equals, it's real easy to go back and figure out what x equals. I just go back up here. So x is equal to 200 minus 150. x is equal to 50. So now we have to answer the question, how many of each type of room does the hotel have? So the hotel has 50 rooms with kitchens, right? Because that's what our x equals. And 150 rooms without kitchens. So that's what we want. Okay, Peanut wants to sell 35 pounds of nuts for $3.05 a pound. Nut has cashews selling for $3.25 per pound and Peanut selling for $2.80 per pound. How many pounds of each type of nut should be in the mixture? So the best way to do this is to set up a little bit of a scorecard. Okay, so we know we're going to have cashews, we're going to have peanuts, and then we're going to have our mix. Okay, so we know we have price per pound, we have the number of pounds, and then we have the total cash that we make. So the price per pound times the total pounds equals how much money we're going to make. So cashews go for $3.25 a pound. Peanuts go for $2.80 a pound, and we want to sell our mix for $3.05 a pound. Okay, so for our pounds of each one, we have no idea. We have X and Y, but we know that we're going to end up with 35 pounds of nuts. So we have X pounds of cashews and Y pounds of peanuts, but we're going to totally sell 35 pounds. And then our money, we just have to multiply across. So 325X, 280Y, and then we'll have 305 times 35. So if we add these down, so first we have this equation. We're going to end up with X plus Y is equal to 35. That's our first one. Then we look at the second one, so how much money we're totally making. So we know that we're going to have 325X plus 280Y, and that's equal to 3.05 times 35, which ends up being 106.75. So now I have my two equations, and now I can solve. So I'm going to make this one that y is equal to 35 minus x. You could solve by elimination too. So now what I'm going to do is plug in here for y. So I have 3.25x plus 2.80 times 35 minus x, and that equals 106.75. So now what we can do is slowly start to combine everything. So 325x plus 98 minus 280x, that still equals 106.75. We have 0.48x equals 8.75. X is equal to 9.44 pounds. So now that we found what x equals, it's really easy to find y. We go back to our original, y is equal to 35 minus 19.44, meaning that y has to equal 15.56 pounds. So now what we can do is we can answer our question and say our mix will use 19.44 pounds of what? Well, x was pounds of cashews, and 15.56 pounds of, well, what was y? Pounds of peanuts. That's what we want. Okay? When a crew rows with the current, it travels 16 miles in 2 hours. Against the current, the crew rows 8 miles in 2 hours. Find the crew's rowing rate in still water and the rate of the current. So what we're going to do is we're going to set R to being the speed of boat in still water. And then we're going to say C is the current speed. Okay, so we know that we're going to be rowing with and against that current. Okay, so we have miles per hour. We have how many hours, and that equals miles. So this is the same thing as distance equals our rate times our time. So we know that if we're going with the current, that current is helping us. So the speed of our boat plus the current, and we're doing that for 2 hours, tells us how many miles we get, and we know that we got 16 miles. When we went against the current, we had our rate of the boat, but we were slowed down by the current for 2 hours, but we only got 8 miles. So now what we want to do is we want to set these two equations up. So I have that 2 times the rate plus the current is equal to 16, and 2 times the rate minus the current equals 8. So I can simplify those. That's our system. Divide both sides by 2. So we have rate plus current equals 8, rate minus current equals 4. So this one's perfectly set up for us to do elimination. So I know that the C's go away, and I have 2R is equal to 12, meaning that the rate is 6. And now what we want to do is figure out the rate of the current, so we can go back and plug into either one of these. So rate plus current equals 8. 6 plus C equals 8. C has to equal 2. So now to answer our question, the rowing rate in still water is 6 miles per hour, and that's because of right here. We know that R is the speed of the boat in still water, and so that the rowing rate in still water is 6 miles an hour, and the rate of the current is 2 miles an hour. And that's because of what we got right here, which is the speed of the current.